A significant part of learning physics is making mistakes. Mistakes may be algebraic, numeric, but also verbal. You must learn to analyze statements for accuracy. Keep in mind that some statements are true, but only under very specific circumstances. Here are some guidelines for your statement analysis. Read the statement as you would any other problem, underlining all the key quantities or principles stated. Check how the variables mentioned in the statement are related by describing their equations. If the statement mentions directions, check that the relevant variable is in fact a vector. When vectors are involved, or there are multiple events mentioned, you can start by drawing a picture and describing it. Sometimes the misstatement is a corruption of a physical law or principle. State the correct law or principle in its entirety. Sometimes the statement can be true, but only under very specific circumstances. You can give a counter example to the misstatement by altering one of those circumstances. Now make sure to clearly state your correction to the misstatement. Finally, as with all problems, reread it to make sure your response answers it sensibly. Example 1. If the acceleration is opposite the direction of the initial speed, then the object is slowing down. The key quantities to highlight are acceleration and speed, as well as the relationship of their direction and the effect. You can first check the relationship they may have through an equation. You can also state the definition of acceleration. Because direction is mentioned, we check if the relevant variables are vectors. These will make us realize that the offending word here is speed, which is not a vector. The correct statement should read, If the acceleration is opposite the direction of the initial velocity, then the object is slowing down. Example 2. Friction slows down objects. We highlight friction, which is a force, and slows down, which implies acceleration. Force and acceleration are related through Newton's second law, which you can then state. You may already notice that it is the net force, not friction alone, that causes acceleration. You may, at this point, state under what circumstances the statement is true. To answer the misstatement, our correction specifies the conditions of a counterexample in which the misstatement is false. Note, there could be multiple counterexamples. Now you try example 3. An object with zero net force on it is stationary. Please pause the video and try to figure out the answer on your own. Is your answer ready? This was a misstatement of Newton's first law. Your answer should have been the correct full version of this law. It is to your benefit to keep this checklist ready to practice in class when the opportunity arises.